Welcome to Spring LIB.
All right, so two particles moving towards each other with the same velocity. So same mass particles moving with the same velocity, same magnitude of velocity, so equal and opposite velocities are in play here. And they produce a particle that's at rest. Okay, so V equals 0. This particle is mass big M. So from equation 26-6b, we know that the total energy is given by gamma mc squared. And so for these two particles, and so if we demand energy conservation, then, which we do in physics generally, especially in intro physics and undergrad physics. And so you get, initially you have two of these particles, so 2 times gamma mc squared. Remember, they have the same velocity, just opposite directions, so same gamma and same masses. And so that will have to be your final energy, which is just m big MC squared. There's no gamma here because, well, gamma is equal to 1 because this particle is at rest, okay? Velocity is 0. All right. So you can cancel the c squares, of course, and write things down in terms of by making big M the subject, which is 2 times gamma times small m. And so writing out gamma in its full form, it's 2m over square root of 1 minus v squared over c squared. So that's your mass. Okay. And so it's an inelastic collision, so energy is conserved. And by energy conservation, obviously, we explicitly assumed, I should say, the energy is conserved. So no energy is lost. Is lost here. So there's that. And finally, we want to find the amount of kinetic energy that is lost. And so kinetic energy is given as, remember, gamma minus 1 times mc squared, right? And so we have two identical particles with the same velocity, same magnitude of velocity and mass. So in this case, we have, so initially we have 2 gamma minus 1 times mc squared. So that's Ke initial. And then finally, we have a particle at rest. So Ke final is 0, right? And so the change in kinetic energy should be equal to the initial kinetic energy minus the final kinetic energy, which is just 2 times gamma minus 1 times mc squared. And so writing out gamma, you have 2 mc squared times 1 over square root of 1 minus v squared over c squared minus 1. And that's your answer.